So to start, if we had 6x cubed y squared divided by 8x squared y cubed, we can rewrite this as a fraction. And then this is stuff we've dealt with before. So 6 divided by 8, we can factor out a 2 from both of them. And we're left with 3/4. Notice here we've got 3x's here, 2x's here. We're left with an x in our numerator and a y in our denominator. Now if we have this problem, we can rewrite this because it's everything in that numerator that's getting divided by the denominator. So we can rewrite this as 8a cubed b to the 4th over 4a squared b squared minus 4a to the 4th b squared over 4a squared b squared. And then this last one. Notice it's that denominator's just broken up into all of them. Just like now, if we wanted to go the other way, there's a common denominator, so you can add your numerators. It follows that same logic. Now this first one, 8 divided by 4 is 2, a cubed divided by a squared is a, and b to the 4th divided by b squared is b squared. This next one, minus 4 divided by 4 is 1, a to the 4th divided by a squared is a squared, and b squared divided by b squared is just 1 as well. Plus, notice here our a's cancel and our b's cancel, so we're left with a 4th. So we're going to have 39 divided by 4. 4 goes into 39 9 times, so we got 36. When we subtract, we have a 3. So we have 9 with a remainder of 3. And remember, we can write this as 9 3/4. So it goes in 9 3/4 time. We're going to use that idea for these next couple. So here is that same thing. We have 2p cubed minus 5p squared minus p plus 1. All of this getting divided by 2p plus 1. You want to look, though, at just what times this first term would get you to this term. And so we'd have to multiply by p squared. And then you're going to multiply this p squared times both of them. It's going to be distributed to both. So we'll have 2p cubed plus p squared. And now remember, we're subtracting this whole thing. So subtracting. So these will cancel, and we're left with negative 6p squared. Bring down this negative p. And now we'll need to multiply this by negative 3p. And when we multiply that, we'll get negative 6p squared minus 3p. Once again, distributing to both of them. And now remember, we're subtracting, so you're going to have to subtract is the opposite of your negatives. So this will go to 0, and we're left with 2p plus 1. And notice this will go in one time. When we subtract, we're left with 0. So our answer is p squared minus 3p plus 1. On this one, it's the same idea, but when we write inside of here, we actually need all the terms that aren't appearing in here. So it'll be a cubed, and 0 for the terms that aren't there. So a 0a squared plus a 0a, and then minus our 1. So now we'd have to multiply this first one by 9a squared. When we subtract, And we'd have to multiply this by a positive 3a. Once again, subtract. And it goes in once, so we add our 1, and we're done because that's a remainder of 0. So our answer is 9a squared plus 3a plus 1. Now this one, even though it's a fraction, we can rewrite it. So when we do our long division, we know this a squared minus 2a plus 1 will be on the outside. Notice though these are not in descending order. We do need it in descending order in order to divide. So let's go ahead and change the order when we get it set up for our long division. So we'll need to multiply this first one by a squared. And when we subtract, we'll now have 5a cubed plus a squared plus a, which means we need to multiply by a positive 5a. When we subtract, it'll change all the signs. And now we need to multiply by a positive 11. So notice now our remainder is not 0. That's okay. So we will write a squared plus 5a plus 11. And then plus our remainder over what we were dividing. So this a squared, what we were dividing by. Notice this was our remainder, and so it's going to go up here. This one, it follows the same idea. It is in the correct order now, so we can just rewrite it. So we need to multiply by x squared. Multiply this one by a positive 3. Left with the remainder of 0. So there's our answer. And that is how you divide polynomials.